So we've seen that there's pretty compelling evidence that the universe is full of supermassive black holes, up to 1 billion times more massive than our sun. But the big problem is, how do we form these so quickly, within 1 billion years of the Big Bang? We know how to make a black hole. For example, a star creating a supernova can easily make a black hole of maybe 10 or 20 times the mass of our sun. But we need to grow that by a factor of 10 to the 7 or 10 to the 8th. And that seems very challenging.
This is not the only mystery, though it's probably the worst one around these quasars at the moment. There are other puzzles. For example, black holes supposed to be powered by stuff falling in, but we never see stuff falling in, or very seldom. All we ever see is stuff coming out, these jets. How does a black hole squirt jets out? It also makes me wonder whether we really are confident there is a black hole here. That has certainly been the consensus theory for 30 years now. But do we really know that it's a black hole in the middle of these things? We can't think of anything else that can do it. We've tried other theories like nuclear fusion, and as far as we can tell, the energy of things falling into a black hole is the only plausible solution. But lack of imagination does not constitute a proof. Maybe there's something much more exotic, like a white hole or some sort of crack in space-time that could produce these sort of things.
Well, Paul, when we look at, for example, the center of the Milky Way or the center of other nearby galaxies where we can see things really well, we can actually see that there is something very massive, 1 million times or 3 million times the mass of our sun, for example, in the center of our own Milky Way. And we can see it because there are stars that are orbiting something that's not shining. It's there, though, and it seems to have that 3 million times the mass of the sun in a very tiny little space. So I think there's pretty strong evidence that black holes really do exist of this size.
Or at least something very dark and very small, which certainly sounds like a black hole, very dark, small and massive. How will we ever... Cut that for a bit.
So we're going to cut on that.
Okay, and then I'll start again in a sec.
So I think what we should do to make it smooth is come in on Paul directly. That'll make a nice smooth cut.
Yep.
And then go wide again.
Okay. So I will launch in...
So look at the camera,
yep.
and then that'll give us a nice smooth cut.
Yes, I was going to say... what was I going to say? That...
I think you should just ask a question.
Yeah.
So
that leaves us with a problem that how to make things so big so soon, and then you can talk about how we might go about solving this.
We need additional proof.
Yep.
So.
Yep.
Yeah.
Okay, so ready for me to restart in a second, and I'll camera on me, but I'll be facing Brian.
Yeah.
So if it really is a black hole that's powering these things, that takes us back to our original problem. How did it get so big so very early in the universe?
So, like any problem, I think the answer requires more data. And one of the great things over the next 10 to 20 years is we're going to have some really interesting data. We have these giant new telescopes in the form of the James Webb Space Telescope and the extremely large telescopes. They're going to be able to look back very close to the time of the Big Bang, much closer than we can see now. And perhaps we can actually see the growth of these quasars in action. And there's even wilder ideas. These new gravity wave detectors like LIGO might actually be able to see gravity waves from black holes, for example, merging and being created in the early universe. So I think the future is bright to unlock this mystery.
Though my prediction here will be that it will solve this mystery at the cost of producing a new and more baffling different mystery that we can't even speculate about at this point.
Yes.